Good day everyone, I am Shane Marita Gem Turkey and today's lesson video is about area measurement using Planimeter and Simpsons method. But before we dig this lesson, let us first test your knowledge in this short motivation, which is the true or false. So in this scenario, I want you to read silently and I will give you 10 seconds to answer these questions. Are you ready? Let's start. Alright, time's up. So all of your answers are correct. So 1, 2, and 3 are all true, while number 4 is false. And now you already have the knowledge about what will be our lesson for today. First, we have the objectives. So, distinguish the use of Planimeter and Simpsons method. To recognize the different methods in using Planimeter and Simpsons method, and understand and learn how to use these methods in area measurements. The first method is Planimeter, also known as platometer. It is a measuring instrument used to determine the area of a two-dimensional shape, and it is a tabletop instrument for measuring areas, usually the areas of irregular regions or map or photography. And there are two types of planimeter. We have the polar planimeter and the linear planimeter. As you can see in the picture, they are different from each other. The two planimeters differ in the movement of the end of the tracer arm opposite to the tracer point, and I will explain that one by one. So let's have first the linear planimeter. So that ends is restricted to move along a straight line from the word linear. The drawing suggests that it runs along a track, but a more common way to cause this motion to move this end attached to a set of wheels that are fixed to an axis so that the wheels turn together. While the polar planimeter, the end opposite the tracer point, is restricted to move along a circle. From the word circumferential, this is done by making that the point, which is the hinge between the tracer arm and a secondary arm, one end of which the pole is fixed. According to my research, polar planimeter is commonly used. Why? Because polar planimeter is restricted by design to measuring areas within units determined by its sides. Unlike linear type has no restriction in one dimension because it can roll. Its wheels must not slip because the movement is be constrained to have a straight line. And now let's move on to the various components of a planimeter. So we have here the tracing arm. Tracing arm is an arm which manages the position of tracing point at one end with the help of hinge. Tracing point is the movable needle point which is connected to tracing arm. This point is moved over the outline of area to be measured. We also have the anchor arm. It's used to manage the anchor position or needle point position on the plan. It is one end is connected to weight and needle point and other end to the integrating unit. Then we have the weight and the needle point. It is also called as anchor. A fine needle point is located at the base of the heavy block. This needle point is anchored at required station on the plan. Clamp. It is used to fix the tracing arm in standard length without any extension. Hinge. The tracing arm and anchor arm are connected by hinge to the integrating unit. With the help of this hinge, the arms can rotate about their axis. We have tangent screw. It is used to extend the tracing arm to the required length. We have here the index. It is a location where all the measuring arrangements like wheel, dial are located. We also have wheel. Wheel is fixed in the integrating unit which helps to measure the tracing length. It is used to set zero on the scale. We have here the dial. Dial is nothing but scale which is to be set zero at the initial level using setting wheel. And lastly, the vernier. It is attached to the wheel as rounded drum with graduation on it. It is divided into 100 parts. So that's the various components of a planimeter. This picture is an example on how to measure an area using a polar planimeter. But to fully understand what is polar planimeter or planimeter, I have here a short video.
This is a polar planimeter, probably from the 1960s. Actually, it's a THS Charvaz compensating polar planimeter with zero set device. With the original case. It's got two arms. The weighted arm that stays put, and the tracing arm with the roller on the bottom that moves around. This is the tracing lens, which has a little bullseye. You trace around the edge of a shape, and the dial tells you the area. A planimeter measures the area of a shape just by going around its perimeter. When I first heard about this device, I thought it couldn't be possible. See, two shapes with the same perimeter can have very different areas. Like this circle and this long rectangle have the same perimeter, but the circle's area is much bigger. So how could anything measure the area just by measuring around the perimeter? Well, the planimeter isn't just measuring the distance around the perimeter. It also takes into account the way the angle here changes as you go around. That extra piece of information makes all the difference. It's pretty amazing you can actually make a device that does this. The nuts and bolts of it is really simple. This wheel just rolls when you move the measuring arm, and that same rolling wheel tells you the answer. No fancy gears, no nothing. The angle is accounted for because the wheel is set away from the pivot, so changing the angle will move the wheel. Here's how you use it. First you got to set it upright. This thing has a weight on the end that's not supposed to move. It's got a little spike on the bottom to help it stay put, and you can help even more by putting it on something like this flat rubber piggy I got. Then this peg sits in the little hole on the measuring arm. Now get yourself something you want to measure and choose a starting point. Before you start going around, get yourself in position and hit this button to reset the dial to 0. A lot of planimeters don't have a 0 button, so this is a bit of a deluxe feature for this model. Now you trace around the figure going clockwise, and once you've gone all the way around, the answer shows down here. This planimeter reads in square inches, and you read the answer by lining up the 0 on the left with the dial on the right. So this would be 0 square inches, and this would be 2 square inches. This here would be 0.7. The round flat dial on the right is for tenths of inches, so this reading would be 34.3 square inches. The big 3 over there means 30, and then you got 4.3 on the measuring wheel. Let's do a little check to see if it's working right. Here's a rectangle that I drew measuring 2 inches by 4 inches, so when I measure the area I should get 8 square inches. Looks like I got about 7.7, which is pretty good, I guess. Now let's do that.
The video also represents the procedure for finding the area with a planimeter. And now let's move on to the formula of a planimeter. The formula for a planimeter is the area is equal to M, open close parentheses, FR the final reading minus the IR the initial reading is equal to -10 and plus C close open parentheses. The M is the multiplier, the N is the number of times the 0 mark of the dial gauge passes the fixed index mark, and C is a constant. Now let's have some examples on how to get the area of a planimeter. Example: find the area of a zero circle from the following taken using planimeter having m plus 100 square centimeter observations. Let's compute first the outside of the figure. The initial reading is 8.596 and the final reading is 4.149. So here we have the M100, we have the initial reading 8.596, F, the final reading is 4.149, and C is the 0, and N is the positive and negative sign. To find the area, so 4.149 minus 8.596 plus 10 times 1 plus 0 is equal to 555.3 centimeters squared, where the anchored point is in the outside. And we're not done yet. Let's calculate the anchored point is inside. We have the initial reading. We have 3.944 and the final reading is 6.534 and N is equal to 2. So A is equal to M open close parentheses F minus initial reading, which is the I, and the positive and negative sign, then 10 and plus C close parentheses. So we already have the outside, which is the 555.3, and now let's compute the inside. So 555.3 is equal to 100 open close parentheses. So first let's fix this. So first is 6.534 minus 3.944 minus 10 times 2 plus C. So the answer of that is 1741. And then we will add the 555.3 plus 1741 is equal to 22.963, which is the C. And then to find the area of a zero circle, we have here the area is equal to 100 times 22.963, so the answer is the 2296.3 centimeters squared. Another method in area measurement is the Simpsons rule. It's used to find the value of a definite integral by approximating the area under the graph of the function of the f and x. When using Riemann sum, we calculate the area under a curve by dividing the area under the curve into rectangles, whereas while using Simpson's rule, we evaluate the area under a curve is by dividing the total area into parabolas. This figure represents as a parabolic rule. So Simpson's rule, the boundaries between the ends of ordinates are assumed to form an arc of parabola. In this rule, we have the three consecutive ordinates, the 0, 1, 0, 2, and 0, 3. Then we have D, the common distance between the ordinates, and the area AFEDC is equal to the area of the trapezium AFDC plus area of segment FEDEF. So here is the step-by-step to get the area between the first two divisions. So we have the area of trapezium, the area of the segment, then we get the first two divisions, which is the area of 1 is equal to 0 sub 1 plus 0 sub 3 over 2 times 2d plus 2 over 3 times close open parentheses 0 sub 2 minus 0 sub 1 plus 0 sub 3 over 2 close open parentheses times 2d. So the area of the next two divisions is area of 2 is equal to z over 3. Then we have 0, 1 plus 4, 0, 2 plus 0, 3, and so on. Take note that we are referring to the figure that I've presented to you. So the total area is this, or what we see. So we have here the common distance is over 3, which is the first ordinate plus the last ordinate, plus 4 from sum of even ordinates, and plus 2 of sum of remaining odd ordinates. I will show you here. Now let's have the area of measurement. So to the sum of the first and the last ordinate, 4 times the sum of even ordinates and twice the sum of the remaining odd ordinates are added. This total sum is multiplied by the common distance. 1/3 of this product is the required area. Here we will total the area. See, the common distance is D is equal to 25. Then the area is d over 3, then 0 sub 1 plus 0 sub 7 plus 2, then 0 sub 3 plus 0 sub 5 plus 4, 0 sub 2 plus 0 4 plus 0 sub 6. Is equal to 25 over 3, open parenthesis, 3.6 plus 4 plus 2, open parenthesis, plus 6.5 plus 7.3 close parenthesis, plus 4, open parenthesis, plus 5 plus 5.5 plus 6 close parenthesis. So in all, the total area is 843.33 square meter. This rule is only applicable when the numbers of divisions is even. The ordinate is odd, so that gives more accurate result. Another term of Simpson's rule is one-third rule. So this rule is one of the most popular methods of finding the area for a given set of points by the method of numerical integration. The basic idea is to divide the x-axis into equally spaced division as shown and to complete the top of these strips of an area in such a way that we can calculate the area by adding up these strips. So as you can see here, the P1, P2, P3, P4, P5, the Y1, Y2, Y3, Y4, and Y5. Then we have the A, H, and B. So in this one-third rule, the important points to be considered while applying this rule is the number of interval must be an even number, and minimum of 3 points are required, then intervals are expected to be equal. So here we have the example. Take a look deep this example. We have some labels and then we will go through about it. We have here the cutting area first. We have the easting, the initial level, the final level, and the cutting depth. And we have here the calculation of an area of square meters by using Simpson's one-third rule. So the formula of this h over 3, the first value plus the last value plus 4 times sum of the odd values plus 2 times sum of the even values. So here h is equal to, as you can see, the 21 over 3 is equal to 3 is equal to 3 over 3, open parentheses, then we have the 0.70 plus 0 plus 4 times 0.5 plus 2 times 0.1. In all, if you total that, the total is 2.9 in cutting area. After the cutting area, we have the filling area. Also have the easting, initial level, final level, cutting depth, and the calculation of area square meters by using Simpson's one-third rule. So h over 3, first value plus the last value plus 4 times sum of odd values plus 2 times sum of even values. So here it is the h is equal to 21 over 3 is equal to 3. So is equal to 3 over 3, open parentheses, plus 0 plus 1 plus 4 times 1.1 plus 2 times 0.4 is equal to 6.6. Fully understood, so we have here the summary table of some of the cutting and filling that we use the Simpsons one-third rule. So we have here the section 80, the trapezoidal method. We have the cutting and filling. Then we have the net area, also include the cutting and filling. Then also the Simpsons rule, which is the result, which is the 2.9 in cutting, and in filling is 6.6. In order for you to understand how to use Simpson's rule, then we have here workout problems. Problem 1. The following offsets were taken from a chain line to an irregular boundary line at an interval of 10 meters. So we have here the 0, 2.50, 3.50, 5.00, then 4.60, 3.20, then 0m. So compute the area between the chain line, the irregular boundary line, and the end of offsets by. So here the distance is 10 meters. The required area is equal to 10 over 3, Then we have here the 0 plus 0 plus 4. Then we have 2.50 plus 5.00 plus 3.20 plus 2 plus 3.50 plus 4.60. So is equal to 10 over 3, open parenthesis, 42.80 plus 16.20, close parenthesis, is equal to 10 over 3 times 59. So the total is 59. We have already the result, which is the 59.00. So in this scenario, we have to work out this. 10 over 3 times 59 is the result, or the answer is 196.66 meters squared. So that's the compute between the area between the chain line and the irregular boundary line in the ends of offsets by using the Simpsons rule. For more information and knowledgeable ideas about this method, kindly visit these references. Thank you and God bless.